Alright, so when I was doing the video, I don't think I really explained well enough what a piecewise function was. So is the relation defined by the following piecewise rule of function explained? Yes, it is. Only certain x values can be plugged into a given piece. That's what makes it a piecewise function. I can't feed 2 to both pieces. Now, you don't know what a function is yet. You probably don't remember the definition from Algebra 1, but if I fed a 2 to both pieces, I'd have 2 different outputs. That makes it not a function. So there's the reasoning on that. Graph the following. 4 is legit the easiest one on here, but it will be left blank by so many kids. God bless you. Anyways, I'll do 3. Let's make some tables. That's all this stuff is. I don't even know that you need a table on number 4. You'll probably ask me about it because you don't know what y equals 1 looks like. That's your problem. But anywho, on to 3. We're going to feed it a -10 and a -3. And I'm going to circle that -3 because there's no equality. Pay attention to that. If I feed it a -10, a -10 squared is 100, but the negative outside is making it negative. It's -99. -100 plus 1 is -99. If I feed it a -3, I'd get +9, but then it's negative. -9 plus 1 is -8. Like this point's going to be off the grid, plain and simple. Let's see, the next guy, we can feed it both a -3 and a 3. And it's x squared minus 9. We also need to do a 0. Remember I told you on the parabolas, do your zeros? If you feed it a -3, you'd have 9 minus 9, which is 0. If you feed it a +3, you'd have 9 minus 9, which is 0. If you feed it a 0, you'd have -9. Alright, the last piece here is going to be 2x plus 1. We're going to feed it 3's and 5's, even though we shouldn't. We're going to open hole them. If you feed it a 3, you'll have 7. If you feed it a 5, you'll have 11. And, you know, we're not going to be able to graph this one. It's like off the grid, okay? -3, -8, we can do that. I think that's 8 tick marks. And that one's open hole. That's part of a parabola. Remember the mom functions? It looks something like that, okay? You need to be showing off your curvature. That is a parabola. Let's see, we have -3, 0, we have +3, 0, and since we crossed the x value of 0, we also have -9. Both closed. And then we have 2x plus 1, which is a line. We contain 3, 7. Open hole. And we contain 5, 11. 9, 10, 11. Also open hole. There's your piecewise function. Didn't actually ask for domain and range. There you go. Easy peasy lemon squeezy. 4, I think, is what we call it. Looks like a step function almost. Should be a set of steps. And not interested in 5. Let's do one of these. Write a rule. Of course, it's kind of hard to tell where your x and y axis are on these things. I mean, it says y there, but it'd be nice if it was like bolded or something for you. Alright. So let's look at this piece. That piece is decreasing by 1 and it's going to cross the origin. So one of your pieces is simply -x. And I wish I could make that click for some kids, but you ain't tried hard in math in a long time. And God love you, I ain't got time to reteach baby stuff. It is valid between -3 and -2. A lot of times, I may not have done this in notes, but if x is stuck between -3 and -2. Alright, we have a constant here, that's y equals 1, and it's valid between -2 and 1. Notice where I'm putting the equality and where I'm not. Solid dot is equality, open is no equality. And then we have this one. This looks like one that's straight out of the notes, actually. It has a slope of rise 4, run 1. Think mx plus b, crosses at -5. If we are between 1 and 2 inclusive. There you go. That's how hard that was. Easy peasy, lemon squeezy. Alright, write the absolute value function f of x equals 3 times x plus 1 as a piecewise defined function. And a picture is always worth 1,000 words. So let's pull that 3. And let's take a look at the graph. That'd be a shift left a third. Then we would rise 3 and run 1. And this is very important because that's kind of like the inflection point. Something happens when x is -1/3. You become one of the two equations. Remember the first step in solving absolute value after you isolate is to write two equations. You've got a piece that's 3x plus 1, which is the right piece, and the left piece when you change signs. Now, the deal here is x is less than -1/3. On the other side, x is, and we'll use greater than or equal to. One of those has to have equality. You pick whichever one you want, but one of them has to have equality. And that's looking at absolute value as a piecewise function, because it is. Alright, 9 is for y'all. I think there's, yeah. Determine the domain and range of each function below. It's about pictures and tables and stuff, okay? So let's look at 3. X is less than 1. So I'll put the 1, and then maybe I'll put something like -10. Or I don't even know if I need that. But maybe 0 and then -1. And the idea is I can keep going. That's the big deal. If I feed it a 1, I get a 6 back. If I feed it a 0, I get a 5. If I feed it a -1, I get a 4. That's enough information to graph. Last I checked it was. If I feed it a 1, I get a 6. Open hole. If I feed it a 0, I get a 5. If I feed it a -1, I get a 4. And this one's going to run forever to the left. Alright. The other guy, x is allowed to be bigger than 1. So if I feed it, and I'm going to feed it a 1 even though I shouldn't. If I feed it a 1, I'm going to get -6. If I feed it a 2, I'm going to get -7. And I could feed it a 3, a 4, and so forth, but it would look like that. Okay, so this is an interesting one. Its domain, -infinity all the way to 1, and it isn't closed by the other function, and the other function starts over just on the right of 1 and moves right forever. Or, this might be easier for you to write, all values of x such that x is not 1. The range is a tough one. Remember, range is values of y. This one is falling to -infinity. It starts at -infinity, and it rises to a peak y value of 6. And actually, there's nothing there, because that was an open hole. Now, this one starts at -infinity and rises to a maximum y value of -6. But we don't need to talk about this one, because this one's already covered it. That's one of the hard parts too. Which one do I need to talk about? This one wins the war of the ranges. So when you're doing these, just think about the graph. A picture's always worth 1,000 words. Or you can be that loser who doesn't graph them and doesn't know what's going on. And yes, I said loser. Because you are losing out on points. You are losing out on your grade. I'm not calling you a loser per se, but you're acting like one. Stop acting like a loser and do your work. It's really that simple, kids. Do your work and you'll be okay. Just do your work. Make tables. Draw lines. This is not upper level math yet.